So this is the third lesson, working with probability. We covered this in 4th, 5th, and 6th period today, and it'll be in 8th period, 1st period tomorrow. And the warm-up is if I flip a coin, it has a chance of landing on either heads or tails. What is the probability that it will land on tails? Well, if we remember our formula, the number of ways it can land on your outcome goes on top, so that's 1. There's only one side that says tails. And then the number of total possible outcomes is the bottom, and the outcomes are either head or tails, so 2. So it's a 1 out of 2 chance, 1/2. If I flip a coin 10 times, how many times should I expect it to land on tails in theory? Well, about half the time, so 5. So 5 out of 10, which is the same as saying 1/2. And this is just to remind us of converting fractions, equivalent fractions, because we're going to use a little bit of that today. Our objectives are we will compare probabilities in experiments with different amounts of outcomes, and we will convert fraction probabilities to decimals to help make comparisons. So we had a quick warm-up. We're going to spend some time on comparing probabilities with spinners as an introduction. Then we're going to work on finding a reliable method of comparing probability fractions with different amounts of possible outcomes. The kids get some time to try it out while I go around and check homework. And then there's the closure, and if anything runs short, or if there's extra time, or if the student gets ahead, then they can do the more practice section on the back. So we have 2 spinners here. One of them has CREEP, creep. One of them has EVEN, CREEPEIR, even creepier. And it says Jose spins each of the spinners below 1 time. What is the probability of landing on C? Well, for spinner 1, C is 1 out of 5 pieces, so 1 out of 5. For spinner 2, C is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces. So that'd be 1/12. And then it says which probability is higher. Well, this is pretty easy because you can look at the spinner and you can see, well, there's a lot more space to land on C, so 1/5 is a higher probability. I got a better chance on the spinner number 1. Then what is the probability of landing on R? Well, spinner 1, R is 1 out of the 5 pieces, so it's still 1/5. On spinner 2, we have 2 R's, so it's 2 out of 12. And this one, it gets a little harder to tell which probability is higher. And there's a couple ways to do it. A lot of kids will just say, well, 2 pieces would fit inside one of these pieces and still have room left over. Like these both start in about the middle, and this one ends over here, and this one ends a little bit further up. It's a little bit of a steeper line. But a more scientific way to do it would be to reduce this fraction, divide by 2. 2/12 is the same as saying 1/6, and 6 are smaller than fifths. They have to be, because if I wanted to fit 6 pieces on here, then I'd have to make all the pieces a little bit smaller. So fifths are bigger, so you have a better chance of getting the 1/5 than the 1/6. Spinner number 1. Then we have E. What is the probability of landing on E? Well, 2 of the pieces out of 5 are E over here, so 2 out of 5. Now here we have 1, 2, 3, 4, 5 pieces out of 12. And this is even harder to compare, because 2/5 and 5/12 are pretty similar. 2/5 is a lot of space. Like 5 pieces seems like a lot, but they're very, very small pieces. So the most reliable way that we've already learned is making equivalent fractions. So 5 and 12, I can count by 5s and by 12s to get to 60. So I'd make new fractions. And 5 times 12 is 60, so 2 times 12 is 24. And 12 times 5 is 60, and 5 times 5 is 25. So this one is bigger, but just barely. It's 1/60th bigger. Okay, and then we have, on the next page in the kids' packet, this question. Why is this important? To answer the question, we're going to answer a slightly different question. If I can win a game by landing on C, and I get to pick which spinner I want to use, which spinner should I pick? And the kids are pretty good at saying, well, you want the one with the better chance of landing on C, the one with the bigger piece for C, so spinner number 1 gives you a better chance. And that's what comparing probabilities is all about. You might have circumstances where there are different chances and you want to figure out which one's better for you. So we need a reliable method, because right here there are 5 probability fractions below. Which one is the most likely? But these are very, very different. 3/4, 29/40, 33/50, 16/25, 25/32. I mean, I could find a common denominator for all of them, but it's going to be a big common denominator. So, I would say we need a more reliable method, but probabilities can also be represented as decimals, so we're going to try starting there. So something that is impossible has 0 chance of happening. When we say impossible, it means that that's not going to happen. So 0 is the lowest probability that we can have. Then again, if you have 12 red marbles in a bucket, you have a 12 out of 12 chance of drawing a red marble. So that's the same as saying 1 hole, which is the highest probability you can have. So probabilities can be represented as decimals ranging from 0 to 1. So it's always going to be 0 or between 0 and 1 or 1. So it's never going to be like 1.2. We're going to look at some common probability fractions written as decimals, and going through the classroom, it's pretty easy to find kids who can just tell you, oh well, 1/5 is 0.2. We might go through the reminder of this is 2/10, so if I multiply by 2 on the top and the bottom, then I get 1 times 2 over 5 times 2 is 2 over 10, 2/10. Then 1/4 is 25/100. This is 4/10. This is 5/10. This is 6/10. 75/100. And 8/100. And 1/10. And again, for any kids that need a reminder, we want to get 10 or 100 or 1,000 or another decimal denominator. So we look at what is the quickest way to get us there. Well, 5 times 2 gets us to tenths. 4 times 25 gets us to hundredths. And 1 times 25 is 25. Times 2. 2 times 5 gets us to 10. 1 times 5 is 5. 5/10. Tenths. Times 25 again. Times 2 again. And 1/10 is already a decimal fraction. I just rewrite it as 1/10. But how can we easily convert any probability fraction to a decimal? Because these are pretty basic, but you might get something harder, like something out of twelfths. Twelfths don't go quickly and easily into a multiple of 100. A multiple of 10. Power of 10. So, what we do is we divide the numerator by the denominator. And at this point, I pass out calculators and let the kids check it, make sure it works. This is a unit that allows calculators. We'll also show them by hand, but since they'll be using calculators, and realistically in life they're going to have calculators available to them, 1 divided by 5 is 0.2. That's the numerator, the top number, divided by the denominator, the bottom number. And 1 divided by 4 is 0.25, which is what we got. And 1 divided by 2, if I skip over 1/2, is 0.5, just to show that it works. And then we go back and we see how it can help us order these fractions, because these are not simple, not quick and easy, but we can convert them into decimal fractions by using division, or decimals. So 3 divided by 4, we should already know that from our common ones, but 0.75. 29 divided by 40, 0.725. 33 divided by 50, 0.66. Some of these are easy without the calculator, like I know 2 50s makes 100, so 2 33s makes 66. But 16 divided by 25 is 0.64 times 4 times 4. And 25 divided by 32 is, here's a harder one, I tell the kids we're going to stop at the thousandths place. So we get 7, 8. Then we need to know, do we need to keep the 1 or do we need to shove it up? Well, you look at the 2 and the 2 tells you to let it go. So we're going to keep the 1 and let the rest go. And then it can be easier to compare for some kids if they add 0 so that they're all the same length. So we'll do that. And then we can actually sort them and say, put them in order, or we can just say which one is the biggest, and in this case, this one is the biggest, because 781 thousandths is the biggest decimal here. Then I go ahead and have the kids try it themselves. They have their calculators, they just do their division. The hardest part a lot of kids have is with the rounding, because a lot of these have repeating digits or really long decimals. Let's see if we can find one. 5 divided by 12 was kind of long. 0.416667, and that is a repeating, like they rounded it on the calculator, but if we want the first 3, we would put 0.41, and then we look at the 6 and we say, are we going to let the rest go, or are we going to give the 6 a shove? Well, 6 says round up, so we give it a shove, 417. And the kids do this. I check homework while they're doing it and answer any questions they have. And then if there's extra, one more. Put these probability fractions in order from least likely to most likely. So you can use a calculator, but make sure you show which is which after you convert. And they have this type of question on their homework, so I actually make sure that we have time to go over this. 25 divided by 84 is 0.297. 6 says give it a shove, so we're going to shove it up to an 8. 112 divided by 300 is 0.37. The 3 has a 3 behind it, that's a let it go, so it just stays a 3. 46 divided by 125 is 0.368. 89 divided by 108, 0.824 has a 0 behind it, so we keep the 4, let the rest go. And 24 divided by 93, 0.25, the 8 has a 0 behind it, so we keep the 8, let the rest go. And then I can actually put them in order. So I'd say, well, these are all 3-digit, so thousandths. 258 would be the smallest, so let me go ahead and cross that one out and put it in the smallest blank. Then, let me make sure I can still see my decimal. This would be next. 25 out of 84. Next smallest is the 368 here. Then 112 over 300, which is 373 thousandths, and then the 89 over 108. And then this is the same way, except for it's most likely to least likely. And here's some practice if the kids get ahead or if they have some extra time. So Kathia cut up the word gave and put the letters in a bag. Then she cut up the word extravagant and put the letters in a different bag. If she pulls out one letter, what's the probability of getting V? Well, for gave, V is 1 out of 4 letters. For extravagant, V is 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 letters, 1 out of 11. And fourths would be bigger than 11, so they would give you a better chance. Less other letters to compete with the V. E, again, is 1/4 here. There's one E in this word, so it's still 1/11, so this is the same. Then here we have A, still 1/4, but there are 3 A's in extravagant, so 3/11ths. And this is one where converting to a decimal is helpful. I know that 1/4 is 0.25. I know that I can do 3 divided by 11. I'm just going to do this one by hand. And 11 goes into 3 0 times. Goes into 30 2 times, which is 22. 8 left over, bring down a 0. 11 goes into 87 times, 77. 3 left over, goes into 30 2 times, and it looks like we're going to have a repeating decimal going on here, because then I'll have 8 left over again, so 0.272 is followed by 7, give it a shove. And 0.273 is bigger than 0.25, I can even add a 0 if it helps, so extravagant has the better probability here. And then there's a few more examples like this: balanced and brilliant, precious and pretentious. And then the kids have the homework, which has one of those, one of the just write it as a decimal, and then also one at the bottom that is more put the probability fractions in order from least to greatest.